This is a short video on the repair of a signal recovery 7280 lock-in amplifier. It had two problems which came with the unit when I bought it. One was a serious problem where the input, it wasn't responding to any inputs, and eventually I managed to find poor cable connection from one board to another board inside the unit, and I managed to properly tighten it and it started to work. The second problem was something I didn't find earlier on because it was more subtle and I hadn't been using the oscillator output as much. But when I was trying to do some measurements at different frequencies, I was seeing that when I connected the output of the oscillator back into the input, I was seeing different amplitudes, and also with different loading conditions, I was seeing different amplitudes. So it was totally unusable, except that it had the frequency, but it was highly distorted, and it was not a particularly good signal for measuring phase and so on. Anyway, I decided to take a shot at looking at the problem and see if I could fix it, even though it's a very complicated instrument with very little access, with multi-layer board and so on. But I just opened it up and I saw that there was a final op amp which was driving the output directly through a 50 ohm resistor, and that op amp was probably the culprit, and I could debug it by just looking at the input of the op amp and then going from there. So we'll look at this repair. It's going to be a short video. Hopefully it helps you to fix instruments that may be expensive but with simple problems. So this is what I could find on the top motherboard or the top circuit board of this signal recovery 7280 lock-in amplifier, showing the output op amp, which is an AD847 analog devices. It was driven by a CMOS switch which selected between multiple clocks, I believe, one of which I think is the PLL clock. T1 is the input to the op amp, and pin number 6 is the feedback, unity gain feedback to pin number 2, which was basically a simple configuration as far as this output was concerned. The only protection or limitation on the output side was a 50 ohm resistor in series that went to a BNC connector, and the rest of the pins are just a couple of power supply pins. So here's the output stage of the lock-in amplifier, oscillator output, and the chip that I removed is right here. If you can see that, it's U50. The output is basically connected, as I mentioned before, on a unity gain non-inverting configuration, where pin number 2 and pin number 6 are connected together, and pin number 3 is the input. Pin number 4 and 7 are the power supplies, plus minus 12 volts. So I'm going to measure those and show you what the current input looks like, and then once I get the replacement chip, I will solder that back in and then see if the output is okay. So here's the 1 volt output that I set into the oscillator output at 1.5 kilohertz, and it looks good at the input of the op amp. Earlier the output was highly distorted with clipping and so on. So once I get the chip back, hopefully I'll see the same output when I drive it into a 50 ohm load or any load. Earlier on it was highly sensitive to the load impedance that was being driven. So this looks pretty good, so just have to wait for the chip, the AD847, to come in. So the chip U50, which is the 847 buffer, has been replaced, as you can see on the board, the one with the red orange dot on it, right in the middle of the screen. And I'm going to now test the output to see what it looks like directly on the both. I'll probe it and as well as to look at the amplitude on the for a loopback test. So here's the output on the BNC directly coming off the signal recovery block going to the oscilloscope, 1 megahertz, 1 volt RMS. It looks perfect. I think you can say that this reference oscillator output is now working correctly. And I'm going to now feed it back into the 7280 input to see what it looks like. So here's the loopback, also now at 1 megahertz, using the internal reference source, and you can see the amplitude is 0.99 volts and the phase is 0.5 degrees. Of course it can be corrected, calibrated out by using the auto function, auto phase, and you can see it's now 0 degrees, so it's working perfectly right now. Trivial repair, but thanks for watching.